Now, it's one thing to configure sub-interfaces. It's another one to verify that they're actually working. And it gets a little bit tricky because the sub-interfaces are traditionally used in a physical environment going to a physical switch. So how in a virtualized environment could we verify that? Well, that, my friend, is the focal point of this nugget. I'm going to walk you through one solution that I came up with where we can actually verify the sub-interfaces are working using virtual switches courtesy of GNS3. Let's begin. In a physical environment, here's how you and I might go about testing this. We'd have our Palo Alto firewall here, and on port, for example, 1/4, it'd be physically connected over to a switch, and this switch port would be configured as a trunk. And then we might have on another port on this switch, we might have an access port. I'll put A here for access, and have a PC. So that PC may be at the IP address of 10.6.6.25. So here's our access port that's associated with VLAN 6, and this green port is our trunk port. So over here on the Palo Alto firewall, we have our sub interface, which is 1/4.6. That sub interface has been assigned the responsibility of VLAN 6 because we assigned the tag of 6 to it when we created it, and the IP address is 10.6.6.250. We also set up our NAT and security policy rules between the guest zone and the outside zone. So all it really takes to verify all this is a PC, a physical switch, and a physical connection between the Palo Alto firewall and the switch. So here's what I thought we could do. Instead of requiring physical gear to do this, because we already have a virtualized machine running as our Palo Alto firewall, here's what I thought we would do instead. On the computer, so this represents the PC that's running this entire environment. On this PC, we're running VMware Workstation. And currently this machine has one physical interface that goes out to the rest of my home lab here. So we'll call this physical network adapter 1. What I did was I put in a second physical network adapter, and I cheated a little bit. I just got one of those like $30 USB Ethernet adapters and plugged it in so I'd have another physical adapter, and we'll call it physical adapter 2. And then inside of VMware Workstation, I created a brand new VMnet, and we'll go ahead and call it VMnet 6. This will be above and beyond any current networking we've configured in VMware Workstation. So this logical network in VMware Workstation, I associated or bridged to this second physical interface. And I also, just for grins, plugged that physical interface into a switch, a real switch, but that was just what had link and it thought it was active. We're not actually going to be using this external network. I just needed a holding place, if you will, so that I could bridge VMnet 6 over to that physical interface. And the reason I mentioned this little external switch that I have it connected to is so that if you want to lab this up and do it at home, you can know exactly what I'm doing. So VMnet 6 and physical interface 2 are bridged, and that's done in the networking settings of VMware Workstation. The next thing we do inside of VMware Workstation is for the virtual machine, the firewall virtual machine, we're simply going to associate VMnet 6 with that final interface. So our interfaces on the Palo Alto firewall are 1/1, which goes to the outside, 1/2, which goes to the inside, 1/3, which goes to our DMZ, and 1/4, which we're now going to associate with that new VMnet 6 logical adapter in VMware Workstation. And we also have our management interface as well that we're using on this virtual machine. Now also on this host computer, on this PC, we can also run GNS3, and we've done that a few times in this course so far. So in GNS3, we could go ahead and create a cloud object, and we could associate that cloud with either physical interface number 2 or with VMnet 6. And the answer to that depends on which one shows up as far as being able to associate it. And it won't really matter in GNS3 if this cloud represents physical interface 2 or VMnet 6 because they are logically bridged together by VMware Workstation. And then check this out. Inside of GNS3, we can set up a little generic GNS3 switch. We can configure it with trunking between the switch and the cloud. And then on the other side, we can have an access port, and we can use the virtual PC simulator to have a single PC sitting on an access port that's assigned to VLAN 6. So the long and the short of it is this. I wanted to give you the background on what we're about to do, and it's all for the purpose of simply verifying in a completely virtualized environment that our layer 3 sub interfaces are actually working and doing the tagging as they're supposed to. All right, so here in VMware Workstation, we're going to go ahead and create a new VM network, a new logical network. To do that, we're going to go up to Edit. From the drop-down, select Virtual Network Editor. From here, we're going to click on the little option that says Change Settings, so we can make some changes. We'll click Yes to the User Account Control dialog window. And what we're going to do is we are going to add a new network. So we'll click on Add, and I'm going to use VMnet 6 just so we can stay consistent with what we talked about. So we'll select from the drop-down VMnet 6 and click on OK. Now, by default, it configured that as a host-only network. We're going to change that. We're going to say, go ahead and we want you to bridge. And from the drop-down, it's showing me the only other network adapter I have available. And that's my little USB 2.0 to fast Ethernet adapter that I have plugged in to a USB port on the physical host that's running VMware Workstation. So effectively, that's bridging this VMnet 6 and this interface. So with that done, we'll go ahead and click on OK. The next thing we want to do is modify the properties of the Palo Alto virtual machine. So we're going to grab that here. So I've selected it here inside of VMware Workstation, and from the drop-down menu, we'll select Settings. Now currently, adapter number 5 is associated with VMnet 3. So just as a reminder, our first interface is the management, then we have the outside, which is 1.1. And then 1/2 is the inside, 1/3 is the DMZ, and 1/4, which is our network adapter number 5, we're going to associate that with VMnet 6. So with adapter 5 selected, we'll go ahead and associate that with VMnet 6 over here on the right, and we'll click on OK. And then we're going to launch GNS3 on this same computer. So with GNS3 up and running, we'll go ahead and build a simple topology. We'll bring out a cloud, and we'll right click on that cloud, select configure. We're going to configure that cloud to represent that second physical network adapter, or VMnet 6, whichever shows up for us. So from the drop down, we have the second adapter, which I named Pluggable. Pluggable is in the name I gave it inside of Control Panel. In fact, just to verify that real quick, let me go to Control Panel. And I just want to show you right here that I named that USB adapter Pluggable. So I'm going to go ahead and close Control Panel. We'll click on Add here. So the cloud is representing that physical network interface. And we'll click on OK. Next, let's bring out a switch. So we're going to drag out a generic GNS3 switch. And we'll also bring out a virtual PC simulator out to the topology. And let's connect these all together. So from the PC to the switch, that'll be port 1. And from the switch going over to the cloud, that'll be port 2. And I'll turn on the labeling tool so we can see that as well. So port 1 on the left, port 2 on the right. And we want to configure this switch so that port 2 is a trunk. And we want to configure port 1 so this is an access port for VLAN 6. So let's go ahead and configure that in GNS3 by right-clicking on the switch, from the drop-down selecting Configure, and let's go ahead and bring up the properties of switch 1. So I'm going to delete all the other interfaces it doesn't need by selecting port number 8 and delete, 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 delete. Just so we have 1 and 2. I'm going to double-click on port 1, which is the port on the left of the switch, and I'm going to assign that to VLAN 6 as an access port and click on Add. So we should see that change over here. Now I'm going to double click on port 2 and I'm going to change that to be a .1Q trunk and click on Add. And we want to verify that port number 1 is an access port for VLAN 6 and port number 2 is a .1Q trunk. So with that in place, we'll go ahead and click on OK. Now we currently don't have DHCP services yet set up on this 10.6.6 subnet. So what we'll do is we'll just manually assign an IP address to this PC. So we'll start the topology by clicking on the Go icon. We'll right click on PC1, from the drop down select console, and let's give this guy an IP address. IP 10.6.6. Let's give him 25 with a 24-bit mask, and we'll say that he should use his default gateway 10.6.6.250. Great. And let's tell it it should use for DNS. Let's use 8.8.8.8. And we'll do a show IP. So on this virtual PC simulator, it's going to be using the IP address of 10.6.6.25, default gateway of .250, DNS of 8.8.8.8, which is great. And our topology would logically look like this. So here's our Palo Alto firewall. It's logically connected to this switch via the trunk. And that's because interface 1/4 is connected to VMnet 6, which is also bridged to our USB Ethernet adapter. And our switch in GNS3 is also trunked to that same logical network. So if PC1 was going to go out to the internet, its traffic would be forwarded into the switch would forward that into the cloud, but it would add the 802.1q tags to it, and then when the firewall received it, it would see the tags. In this case, it would be tag number 6 because the traffic came from a PC in VLAN 6. So on the firewall, that would be processed logically by that 1/4.6 subinterface, and then based on our NAT and security rules, that traffic could be translated and permitted and routed out to the internet. So that's the theory anyway. Let's right click on this link between switch 1 and the cloud and let's capture the traffic. There is some great training also right here at CBT Nuggets on Wireshark as well as GNS3 if you want to dig deeper into protocol analysis and how to use tools like Wireshark. So we'll go ahead and click on OK to start the capturing. And what we see right here, 10.66.251 is an IP address that I assigned to my host, the PC running GNS3 and VMware Workstation. I gave the USB pluggable adapter an IP address of 10.66.251. So it's doing its Microsoft Windows stuff at the moment. So let's go ahead and minimize that and let's do our ping. So we'll go to the console for the virtual PC simulator. Let's do a ping out to www.google.com. So name resolution hopefully will work with DNS, and hopefully the pings will also be successful. Cannot, oh nuts, cannot resolve google.com. I'm going to try that one more time. Press enter. All right, there we go. So that first one could have timed out due to an ARP issue. Because the virtual PC simulator had not yet learned the layer 2 address of the subinterface on the Palo Alto firewall, we can attribute that first one perhaps being eaten up by ARP. So if we did this again and again, it should work again and again. Also, check this out. If we go back to our Wireshark capture of that traffic on that trunk link between the switch and our Palo Alto firewall, check this out. If we take a look at this DNS request, this is in capture number 23, notice here that we have this 802.1q header that's been added. And inside this header, it's identifying the VLAN tag, the 802.1q tag of 6. And when the response came back, the response also included that 802.1q tag. And in fact, all of the traffic that PC generates and is sending out through the Palo Alto firewall, if we look at that traffic on the trunk, it will always include that tag of 6, so that the receiving device, whether it's the switch or the Palo Alto firewall, will know which VLAN that frame is associated with. In this nugget, we've set up some fairly creative methods to verify in a virtualized environment that our sub-interfaces on the Palo Alto firewall are operating correctly. I'm glad you joined me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.